Okay, so we're going to be doing proportions and triangles. You're going to see this on parallel lines as well as we go forward. This is all proportions. It's usually a good day. People tend to do well on this. This is the other half of your test. Remember, the test that we take on Thursday will cover just these two topics. It will only be 7-4 and 7-5, so you've got to make sure you don't miss half of it. If you miss the other set of notes or have questions about the other section, you definitely need to ask as we go forward before we get to that test on Thursday. If you have questions on this one, same thing. So, triangle proportionality. I'm not going to read the whole thing to you. Just understand that if you have a triangle that cuts off two lines and those two lines are parallel to each other, they are going to create what we call proportional parts. So this part's on the outside right here, the AE is going to go, ooh, I don't like that color, is going to go over this ED, and then on the other side over here, you're going to be dealing with AB, the top part, goes over that bottom part over here, which is going to be BC. So it's just going to go top over bottom, top over bottom. Guys, listen to me. It doesn't matter whether you go top to bottom, or bottom to top. It doesn't make any difference. The only problem is, whatever you do on one side, you've got to do the same thing on the other side. They just need to match each other. So in that, looking at the next problem, you're going to find x based on the fact that those lines are parallel. So because we know these lines are parallel, we can just set it up as a proportion. That proportion would have x over 12. And if it's x over 12 on this side, what's it going to be for the other side? Yeah, 36 over 18. Okay. Now, just so you know, some people like to go left to right or bottom to top, doesn't matter, right to left. That gives you the same proportion, guys. I could go x over 36 and 12 over 18. X over 36, 12 over 18, gives me the same proportion. You just can't go like x over 36 and then 18 over 12. You got to go the same direct. Whatever you do, if you go this way, then you got to go down. If you go across, you got to go across. Whatever you do, you got to go the same order. Okay, cross multiply, because that's how we solve every proportion. That's going to be 18x equals, what's 12 times 36? What was 4 what? 432. There you go. Divide by 18, divide by 18. What'd y'all get? 24. Perfect. X equals 24. There you go. So guys, 24 is the value that you get because these lines are parallel. That'll keep these sides proportional. So if you have a 24, 24 over 12 is the same relationship as 36 over 18. Guys, you can see they're twice as big. Okay, 12 times 2 gives you 24, 18 times 2 gives you 36. Anybody have anything? Questions, concerns? Okay, so the same is going to be true when you go backwards before we get to some problems that mix it all up. Guys, converse is true, meaning if the sides are proportional to each other, like 2 over 1 is equal to 4 over 2, if these two sides are proportional, and how do you tell that? You cross multiply them. Now, I will say this. Normally I tell you it doesn't matter what order you do the cross multiplication in. It doesn't matter which two, like if you go up or down. It matters when you compare, because when you use greater than and less than symbols, you need to multiply up and then drop it down. It's kind of like bunny ears. You need to go 2 times 2 is 4 and 1 times 4 is 4. Now these are equal, so it doesn't matter, but if you were putting a less than or greater than symbol, it only works if you go up and drop it down. That's going to be important later on. So because they're equal to each other, you can see the sides are proportional. Now that's going to be true over here. When the sides are proportional, that tells us that these lines are parallel to each other. Because the sides are proportional, then the lines are parallel. So we can say that GH is going to be parallel to FE. GH is going to be parallel to FE. Guys, it's just backwards. If the lines are parallel, then the sides are proportional. If the sides are proportional, the lines are parallel. Alright? But did you notice on the next problem that the questions are asked the exact same way? It says, find the value of x that makes the lines parallel. You still have to set it up as a proportion, and you still have to cross multiply. So it's going to be x over 2.5 equals 7.5 over 3. Perfect. Cross multiply that. Now I can do the 3x, but you know I do not attempt to do decimals. What's 2.5 times 7.5? 0.75. There we go. And then we divide by 3. Divide by 3. I think I can, hold on, don't say it. I can do that one without the calculator. It's going to be 6.25. Okay, but, if this had directions, which all the ones we've been doing, we've been rounding to the nearest tenth. That's what's going to be on your test. So we need to put it as x equals 6.3. Everything we've been doing the same, so I want to stay consistent on the rounding. Okay, anybody have any questions, concerns, anything about it? Forward, backwards? Yeah, please make.
I don't have a calculator.
Oh, let's see. Why has that one not got one? Anybody got an empty desk around them that has one on it? Thank you. Connor, would you give that? Meg, would you grab that? There you go. There you go. Good deal. Thank y'all. We'll figure it out in a minute. Okay, because that one had one. Okay, so from here, we are going to go through and we are going to look at when we have line. Guys, we've done this before. Do y'all recognize this? We set these up before. This was just kind of a review. Notice I only put one like review of the concept and then the problem, because we've really already done this before. Whenever you have lines that are parallel cutting off the transversals, then the parts are going to be proportional. So AB right here over the BC down here is going to be proportional to, on the other side, DE over EF. Okay, AB over BC is going to be proportional to DE over EF. We've done that process before. I just wanted to review it because it's on these. You're going to see more of them. They've mixed it in with this stuff, so I want to make sure you see it. So here we go. Let's take a look at what the problem would look like. Oh, guys, now this is a little different. They didn't put the numbers on the problem for you. All you got to do is go through and label it in order to set this up. The AB right here is 2. The DE right here is 5. The EF down here at the bottom is 6. And when we don't know what BC is, what do we put? X. Perfect. So then you're going to set up your proportion. What would your proportion be on the left? The ratio right here. 2 over X. And on the other side it'd be what?
5 over 6.
5 over 6. 2 over X and 5 over 6. Cross multiply that. That'd be 5X equals 12. Divide by 5, divide by 5, and X equals, what was it? 2.4. Like, doesn't need to round? Okay, 2.4. There we go. Okay, questions, concerns, anything about it? Yeah, please.
Can you go back to the first ratio?
Absolutely. Yeah, the letters.
Yeah.
Okay, you're good. I'll go back to that one. Take it back. Guys, if you ever need me to go back, I will absolutely go back a screen.
Okay, thank you.
You're welcome. Anybody still working on this one? We're good on this one? Okay, here we go. The next one. So this is the one that's the new concept, but the proportions are exactly the same, guys. So the whole idea here is, if you have an angle bisector inside of a triangle, then you are going to find that it creates this relationship between the edges on the outside and the sides that are across from these angle bisectors. It is proportional to each other. It's going to be this outside piece over here, the AB, goes over this piece at the bottom that's connected to it, so the BC. And then on the other side, the one that is on the outside, the one that's here connected to that angle bisector, that one right there, the AD, is going to go over the piece that is connected to it that is across from the angle bisector, that DC or CD. It doesn't matter what order you put the letters in, as long as the letters pairs, like the segments, are in the same spot. Okay? So if I just sat here and had a problem, it would just be this number, the AB, over this number, the BC, and then the AD number over the BC number. We're good? Got it? Okay, here we go. So, set up this problem. You tell me when we set up this proportion, what is going to go over here on the top left? 6. Good. Put this 6, guys. This one on the outside. Over what? Over the 4 that goes on the bottom. And then on the other side, what's going to go on the other side on the top?
X plus 3.
The x plus 3 goes here. And then the x goes on the bottom. You're going to be cross multiplying just like you have on all the rest of them. You may, just so we know this, you may get a quadratic formula where you have to actually factor or use a quadratic formula for it. A quadratic equation may come up. This one isn't, but you may see those on your homework. Number 11, first one. Look out for it. Okay, when we cross multiply, that's going to give us 6x is equal to, now guys, when I multiply this 4, what property is this? Distributive. You've got to multiply to both of them. 4 times x is 4x, and 4 times 3 is. Okay, we are going to minus 4x minus 4x. 6x minus 4x is going to be 2x equals 12. Divide by 2, and x equals 6. Good? Okay. Try looking at the setup, just the setup. Don't solve it yet because I want to make sure you got the setup right, and we're going to talk about some other examples. But try the setup on the next problem. Try to set up your proportion. Okay, guys. What's going to go here?
18 minus x.
18 minus x. Because if you had a length that was 10, and you already used up 4 over here, it's that idea of a part plus a part equals a whole again, then this part over on this side would just be 10 minus 4, which would put it at 6. But we don't have a real number. We have 10 minus something unknown. In this case, we have 18 minus x. So that 18 minus x goes here. That's very different than x minus 18, so you have to be careful. So if we set up this proportion, it would be 10 over 18 minus x equals 14 over x. When we cross multiply that, that's going to put us at 10x is equal to, again, this is distributive property. I've got to multiply the 14 times both of these things. I have no idea. What's 14 times 18? What? 252. Sorry. Minus 14x. That was my fault. Couldn't hear that. Oh, what do we do to solve this? Which one do we move? Yeah, get rid of that 14x. Add that 14x to get it away from it. Makes it 24x equals 252. Divide by 24. Does it divide evenly?
10.5.
Does it need to be rounded to 10.5 or it's just 10.5? Just 10.5. There we go. Okay. Anybody have any questions or concerns? Because I got a couple of things, other things I want to talk about. They're not necessarily ones you need to write down, but I want to show you because there's something you might deal with on your homework.
Are we going over the homework?
Huh?
Are we going over the homework?
The old homework?
The homework that we
No, not yet. I'm going to send out just answers today, and then we'll go over questions to the 2 of them tomorrow since we've got review day tomorrow. Okay? Anybody else? Okay. Before we get done with this, I want to make sure we cover this concept. So let's say I had another problem, we'll use the exact same numbers, and I had across the bottom, I had x, and then this part of it was 18. What's gonna go right here? X minus 18. It's the same concept, guys, it's just the x has to go first because it's the longer one. So it's x minus 18 goes in this spot. Let's say I had another one. Let's make up numbers. Let's say I put over here, this thing is 10 and this one is x. What would I put here? X minus 10. Let's say I did the same thing, but I switched it up. Ooh, that's not a very good line. Let's say I switched it up and I put the x here and the 10 on the whole thing. What would go right here? 10 minus x. You're not having any problems with that. Good. Let me do one more thing. One more thing before we go on. Alright guys, this is just kind of quick, just want you to see it. I want to do this one other concept. Guys, if you have to multiply a proportion, where in that proportion you have something like x minus 1 and x plus 5. Do you remember how to multiply this? What is this called? What's it called? FOIL. Nice. Who said that? Nicely done. FOILing. FOIL. First, outer, inner, last. This is multiplying binomials. This is going to be x times x, which is going to give us what? X squared. And then x times 5, which is going to give us 5x. 1 times x, it's negative 1 times x, be minus x. And then negative 1 times 5 would be minus 5. You would combine like terms, x squared plus 4x minus 5. Now, if this is in your problem and it's equal to something else, okay, you would have to move everything to one side and see if your variables cancel out. If not, your squares cancel out. If not, you would have to solve it with quadratic equation or factoring. You're going to have some of those. That's the algebra, the old stuff. Okay, any questions, guys, before we get started then today?